All right, what's up, future SLPs, and welcome to a special midterm prep edition of Research Rumble. We are about to do a super fast, rapid-fire review of phonetics and phonology and introduction, hitting the key concepts from chapters 1 all the way through 7. So yeah, think of this as your personal study buddy, here to help you lock in all those big ideas before the exam.
Okay, let's just dive right in. This is not going to be one of those passive, sit-back-and-listen reviews. Nope, we're going to put your knowledge to the test. I've got a bunch of quick-fire questions that cover everything from the basic theories to how you'd actually use this stuff in the clinic. So get those thinking caps on. It is time to rumble. First up, we've got round 1, phonology fundamentals. These are the absolute core theories. You know, the blueprint for pretty much everything we do. So let's make sure we have them down cold.
Okay, let's start with the absolute basics. A phoneme, right? It's the smallest little bit of sound in a language that can totally change a word's meaning. Think pa in pat versus ba in bat. So, what do we call that fundamental property? That tiny little thing that helps us tell one phoneme from another? Go on, take a second. Got an answer in your head?
The answer is a distinctive feature. And this concept is so powerful. It uses this really simple plus or minus system to show if a sound property is there or not. For example, the only thing separating the k sound in cat from the g sound in goat is that little plus voice feature. It just means your vocal cords are buzzing. That one tiny distinction, and you've got a completely different word.
All right, next one, true or false for you. Think back to natural phonology. In Stampe's original theory, are kids, active little scientists figuring things out, or is something else going on? True or false?
And the answer is false. Stomp's theory is pretty wild because he believed kids aren't actively problem-solving at all. Instead, he saw them as passively getting rid of these built-in universal simplification patterns as their motor skills get better. The theory basically assumes a kid already hears the adult system perfectly. Their mouth just can't physically do it yet. It's a really key idea, even though other theorists like Kiparsky and men came along later and said, hey, wait a minute, kids are way more active than that.
Okay, time for a real-world clinical question. You hear a kid say T when they're trying to say key. Which phonological process is happening here? A, B, C, or D? Have a look. The correct answer is C, velar fronting. It's exactly what it sounds like. The K sound is a velar sound, right? It's made way in the back of your mouth when your tongue hits the soft palate or the velum. But the T sound, that's an alveolar sound, made right up front with your tongue behind your teeth. So the child is literally moving that back sound to the front of their mouth. Trust me, you will see this one all the time.
Let's keep building on this and talk about optimality theory. This theory is basically a big tug-of-war between two different kinds of rules, or constraints. You've got faithfulness constraints, which are all about be accurate, say it just like an adult. And then you've got markedness constraints, which say, nah, keep it simple, make it easy to say. So look at this example. A kid says sip for skip. Which of those two competing rules are they managing to follow?
And the answer is they're following the markedness constraint. I mean, think about it. Dropping the K from that SK cluster makes the word way simpler to say. That's a classic unmarked simple form. But in doing that, they are definitely violating the faithfulness constraint because sip is not a faithful or accurate copy of skip. In early development, markedness often wins. That drive to keep things simple is way stronger than the drive to be perfectly accurate. You survived the theory round? Nicely done. Now let's get practical with round 2, diagnostic deep dive. This is all about taking those concepts and actually using them to figure out what's going on with a client, just like you're going to do in the clinic.
Okay, a quick fill-in-the-blank for you, just to test your terminology. We're looking at the word banana. Where are those two N sounds located inside the word? What's the fancy technical term for that position?
The correct term is intervocalic, and as you can see, it just means between vowels. Simple enough, right? But here's why this is so important clinically. A kid's error patterns are often position-specific. They might be able to say a sound at the beginning of a word, that prevocalic position, but totally bomb it in the middle. Pinpointing the exact position helps you zero in on exactly where things are breaking down.
Okay, time for a little data analysis. This is a summary of Jonah's speech assessment. I want you to take a really close look at this. Is there an entire class of sounds that he's just consistently struggling with? What's the pattern you see?
If you look at that fricative section, wow, it's pretty much all substitutions. Now, fricatives are those sounds made by forcing air through a really narrow channel, creating that friction, that hissy sound, like s, z, and sh.
Jonah is swapping all these long, noisy sounds with short sounds called stops, like t and duh, where the airflow just gets completely blocked for a second. And this pattern, where a whole class of sounds is missing, that is a huge red flag for a phonological disorder. We're not just talking about a simple articulation error anymore. Here's another clinical example for you, but this one is a little unusual. A child says fuck for duck. Now, this isn't a process you see every single day. What is this uncommon process called? And more importantly, why is it such a big deal when you hear it?
That is initial consonant deletion. And the key word you need to remember here is idiosyncratic. This is not a typical simplification pattern we expect to see in normal development. When you see idiosyncratic processes like this one, it is a very, very strong sign that you're probably dealing with a disordered phonological system, not just a simple developmental delay.
All right, you made it. This is it, the final round, the final rumble. This is where we put it all together. We're going to synthesize theory with those diagnostic principles to solve some tricky clinical cases. Let's do it.
Take a good look at this feature geometry tree. Okay, so a kid is showing that classic fronting pattern we talked about. K becomes T and G becomes D. Looking at this whole hierarchy, can you pinpoint the exact spot, the specific node, where the system is breaking down?
The breakdown is happening at the place node, and here's why that makes sense. The manner is correct. They're still producing stops. And the voicing is right. They're matching voiced with voiced. The only thing that's wrong is where in the mouth the sound is being made. The child is just defaulting to that coronal place, using the front of their tongue, instead of correctly producing those dorsal place sounds with the back of their tongue. So yeah, feature geometry lets us get way more precise than just saying it's fronting.
Okay, for our very last question, let's look at Hector's speech sample here. He says day for grapes, toe for stove, and ut for book. Based on these productions, let's go back to that tug of war. Which constraint is winning in his system? Is it markedness or is it faithfulness?
Oh yeah, markedness is the clear winner here, and it's not even close. Hector's system is doing everything it possibly can to make these words simpler. He's getting rid of clusters, he's deleting final consonants, he's changing sounds. So his system is prioritizing that markedness constraint, the keep it simple rule, at the major expense of the faithfulness constraint, the be accurate rule. This exact ranking, markedness way over faithfulness, is a classic profile for a child with a phonological disorder.
And that is the final bell. You did it! You survived the research rumble. We've gone through distinctive features, natural phonology, feature geometry, optimality theory, the whole shebang. And remember, these aren't just abstract ideas for your exam. These are the actual tools you're going to use to understand, diagnose, and treat your very first clients. So the final question is really for you to think about. Which of these frameworks is going to be your go-to? Good luck on your midterm. You are absolutely going to crush it.